In this video, we are going to talk about sets. We will cover Venn diagrams and set builder notations. So, in these problems, we are going to shade the corresponding regions based on the set builder notation that we have been given. So now, let's come to this place. It says that we should shade the region A. So you see that this circle is the circle that corresponds to what? A. So the region A is all of the circle. This is the shaded region for A. And then when we come here, it says A prime. A prime is also known as the complement of A. In other words, the complement of A is the opposite of A. That means all the other regions apart from A itself. So if this is A, then we are going to shade all the other regions apart from A, and therefore this is A complement. So all of these regions are. So let's come to this aspect. It says A union B. A union B means all the elements of A together with all the elements of B. So these are the elements of A. And then these are the elements of B. So this is the shaded portion of A union B. Then now let's come to this part. It says A union B complement. So A union B complement is all the other region apart from A union B. So if this is A union B, then A union B complement is this outside region. So this is the region that represents A union B complement. Now let's come to this one, which says A intersection B. So A intersection B is the region that is common to both A and B. So if we check this, the region that is common to both A and B is this region. And then here is A intersection B complement. In other words, the opposite of A intersection B. So all the other regions outside of A intersection B. So if this is A intersection B, then A intersection B complement is all of this region. So we shade all the other regions apart from A intersection B itself. And then now, let's come here. A union B complement. So the first thing is that we need to find B complement. So B complement is all of the regions outside of B. And then A. So this is A. All of this region is A. Then B complement all of the region outside of B. So you see that it is okay. So let's first draw a small Venn diagram here. So if this is A and this is B, we are looking for B complement. So all the region apart from B is up. So this is B complement. And then union A. So all of this is A. So A union B complement is going to be all of this region. So A union B complement is this region. So now let's come to this region. And that region says A intersection B complement. So let me first draw a Venn diagram here. So let's assume here is A and then here is B. So let's find B complement. B complement is all of this region outside of B. And then intersection A. So this is A. The region that is common to both A and B complement is only this region. So this is the region of A intersection B complement. Then here is A complement union B. So let's draw a small Venn diagram here. So this is A and this is B. A complement all of the region outside of A. So this is A complement. And then it's in union with B. So all of B must be part, and therefore we need to shade all the regions belonging to B and then A complement. So all of this region is part. And then if we come here, it talks about A complement intersection B complement. So now let's draw a small Venn diagram here. So here is A and here is B. So let's first find A complement. This is A complement, all of the region outside of A. And then let's find B complement. So you see that B complement is also here. So the region that is common to both A and then B is the outside region. This is the only region that is common to both A and B. So this is A complement intersection B complement. So in this case, it says we should find A intersection B intersection C. So that means the region that is common to both A and B and C. So you see that this is the only region that is common to both A, B, and C. So this is A intersection B intersection C. And then here we have A union B union C. So in other words, all of A, and then we add it to all of B, then we add it to all of C. So that is A union B union C. Now let's come to this one, which is A complement union B. So that means all of B must be part of the answer. But let's find A complement. So let's draw a Venn diagram here. A, B, and C. So we are looking for A complement. That means all the regions outside of A. So you see that this region is outside of A, including the outer parts. Then union B. So now that means that all of this region must be part. So A complement union B complement. All of B, sorry, union B. So all of B must be part. Then we'll add A complement to it. And this is A complement. Everything outside of A. And now let's come to this problem. It says A intersection B union C. So you see that this is the region A intersection B. So let's shade that region first. And then this is the region C. So A intersection B union C is this region. Then this final one says A union B intersection C. So A union B is all the members in A, including all the members in B. Now intersection C means all the members in A and B which are common to C. So you see that this is the only region that is common to C, and it is also common to the elements A and B. So this is A union B intersection C. All the students in a class were surveyed regarding what type of pet they owned at home. 25 students said they own cats and 30 students said they own dogs. 13 students said they own neither. Draw on a Venn diagram. Then how many students own cats but no dogs? Then C, how many students own dogs but no cats? And D, how many students are in the class? So let's draw our Venn diagram here. So let's use C for cats and then D for dogs. Now, he says that 25 said they own cats. So the number of cats are 25. And then 30 students said they own dogs. So the dogs are 30. Sorry, I made a mistake in writing the question. So let's continue from there. So he says that 13 students said they own both. So this is the intersection of the cat and dog. So this is 13 students. And then 17 students say they own neither of them. So they are not in the dogs and cat group. So those 17 people are here. So now what do we have? What should we what value should we put for cat only? That's going to be 25 minus 13, and then 25 minus 13 is 12, and then the number of dogs only is going to be 30 minus 13, and that's going to give 17. So let's come to the A part. So you say we should represent on a Venn diagram. We've done that. The B part says how many students own cats but no dogs. So these are the number of students that own cats, but cats but not dogs means cats only. So B, cats only is 12. And then C, how many students own dogs but no cats? So he's talking about dogs only, because the 13 people also own cats and dogs, and therefore C is equal to 17. And then D, how many students are in the class? So the number of students in the class is, you have to sum this, sum this, sum this, and then this one. Another way we can go about it is to sum the 25 plus 30 and subtract it from the intersection. So the number of people, that is the universal set, is equal to 17 plus 12 plus 13 plus 17. And if you do all of this, you are going to get 59. So there are 59 people in the class. Now we have another question. If M and N are two intersecting sets of number of M being 20, number of N being 30, and number of M union N is equal to 40, we are supposed to find number of M intersection N. The number of M union N is equal to the number of M, then plus the number of N, then minus the number of M intersection N. So we are looking for number of M intersection N, so we can make that the subject. So number of M intersection N is equal to number of M plus number of N, and then minus number of M union N. So the number of M is 20, number of N is 30, number of M union N is 40. So 20 plus 30 is 50, 50 minus 40 is 10. So the answer is 10. B and C are subsets of a universal set mu, where B and C are not disjoint and not subsets of each other. Draw a Venn diagram to illustrate it. So let me draw the diagram here. So this is our Venn diagram. And then he's talking about B and then C. So this is B and this is C. And this is the universal set mu. Then now, he says that we should shade the set B complement union C. Now, the first thing is that let's find B complement. So this is A and then this is B. So B complement is all the regional side of B, which is this region. So we are looking for B complement union C. So it means that we need to add all of C into this complement. So this is B complement union C. And then the last part of the question says that we should use set notation to describe the unshaded region. So you see that the unshaded region is B only. So how do we write B only? B only is B complement B only is B intersection C complement. So let's come to this question. P is equal to 1, 2, 3, 4. Write down all the subsets of P that has exactly 2 elements. So the subsets of P are, we have 1 and then 2. This is one set. And then the next one is 1 and then 3. The next one is 1 and then 4. Then the next one is 2 and then 3. Then the next one is 2 and then 4. Then the last one is 3, and 4. So these are the subsets of P. Then when we come to the B part, it says that A is equal to a set of prime numbers less than 15. So let's write the set of A. So prime numbers. So A is equal to, the first prime number is 2. Then we have 3, and 5, 7. We have 11, and then 13. So these are the prime numbers that are less than 15. And then B is even numbers less than 15. So B is 2, 4, 6, 8. Then we have 10, 12, and then 14. Then C is X is said that X is greater than or equal to 3, but less than 12. So the set of C is starts from 3, 4, 5, 6, 7, 8, 9, 10, 11. Now it's less than 12, so we have to end at 11. So the question says that we should find A intersection C. So that means that the elements that are common to both A and then C. So A intersection C is equal to, now if we look through, you see that 3 is here, then 3 is here. So this is 3 is one of the elements. Then there is also 5 here and there is 5 here. So 5 is also one of them. Then there is 7 here and there is 7 here. So 7 is also one of them. There 11. There is an 11 here and there is also 11 here. So 11 is also one of the elements. So this is A intersection C. Then now, the next part. So this is I says we should find B intersection C. So the elements that are common to both B and then C. So B intersection C is equal to, now you see that there is a 4 here and there is a 4 here. So 4 is one of them. Then there is a 6 here and there is also a 6 here. So 6. And then apart from that, there is also 8 in both B and C. So 8. And then there is 10 too. So 10. So this is the set of B intersection C. And then the last part says we should find A union B complement intersection C. So now let's first find the universal set. So let me do the universal set here. So universal set means universal set is A union B union C. The universal set contains all the elements that belongs to both A, B, and then C. We're not given it, so we need to find it. So if you look through, we have 2, then we also have 3, we have 4, 5, we have 6, and then there's also a 7, then we have 8, but then we have 9, and then there is also 10, 11, 12, 13, and then 14. So this is the universal set. Let's first find A union B. So A union B, we have 2, 3, and then there is also a 4, and then we have 5 here. So 5, 6, then we have 7, then 8. Now there is no 9, so we need to skip 9. There is 10, 11, 12, 13, and then 14. So this is A union B. So let's find A union B prime. So the elements that are in the universal set but are not in A union B. So there's a 2, there's a 3, there's a 4, 5, 6, 7, 8. There is no 9, so 9 is one of them. And then 10, 11, 12, 13, 14. So 9. A union B complement is 9. Now intersection C. So you see that there is also a 9 in C, and therefore A union B complement intersection C is equal to 9. Set 9.